to our annual Top 10 podcast. Today we'll briefly describe our choices for the top 10 science stories of 2016. My name is Susan, and joining me in our countdown are some of my education colleagues.
I'm Eric.
I'm Megan.
I'm Corrine.
I'm Marion.
I'm Megan.
And I'm Karen.
In true countdown fashion, we'll start at number 10 and work our way to the number one science story of the year. So let's get started. Marion, what's our number 10 story?
So this year, a group of geologists found potentially the world's oldest fossil ever discovered.
How old is it?
The fossil is actually 200 million years older than the previously known oldest fossil, and it's 3.7 billion years old.
Sounds like a really long time. I imagine we're not talking about a dinosaur. What kind of life was this fossil?
So the fossil they found is actually a stromatolite, which is something we can still find on Earth today. Stromatolites are rock-like sediment structures that are built collectively by communities of tiny single-celled microbes. So we can compare fossilized stromatolites like this 3.7 billion year old one we found to modern-day stromatolites.
So why haven't we found more of these types of fossils?
Well, normally, these fossils are weathered away or destroyed by natural geological activity, so it's really hard to find preserved fossils that are that old.
Okay, our number 9 story is self-driving cars, but these have been in the news for a while, so what's so exciting about them now, Corrine?
Well, we've been hearing about them for a while. They're starting to hit the roads more and more. 4 states and a bunch of cities have already approved self-driving cars. And in September, the federal government put out a set of guidelines to address the safe testing and development of self-driving cars.
So why do we need all those guidelines?
Well, a lot of interesting questions are starting to come up around self-driving cars, like, do you need a license to operate a self-driving car if you're not actually doing anything? And what if a self-driving car gets in an accident? Who's to blame? Is it the occupant? Is it the owner, the manufacturer? So these federal guidelines are an effort to help the states form their own legislation around self-driving cars and have some consistency around that.
I heard they also have self-driving trucks.
Yeah, in October, a company named Otto tested a self-driving truck delivering real cargo 120 miles across the highways of Colorado.
So that's a truck on the highway, but what about these self-driving cars navigating the narrow and winding streets of Boston?
The city's mayor, Marty Walsh, announced plans for self-driving cars to be tested in Boston starting in January 2017. So if you're out on the streets of Boston, keep your eyes peeled because there will be driverless cars out there.
That's a really cool local story. And now for something totally out of this world. Eric, tell us about number 8.
Our number 8 story this year is the discovery of the closest ever exoplanet. We have 8 planets in our solar system. An exoplanet is one that is orbiting another star besides the sun. They're typically extremely far away and hard to study, but we've found thousands of them to date.
And how close is it?
It's as close as you can get as an exoplanet. It's at the next closest star system. It's orbiting a star called Proxima Centauri, which is only 4 light years away. It's close as far as stars go, but it's really far away as far as our spaceships can travel.
How long do you think it would take to get there?
Our fastest rockets would take 70,000 years to make it all the way to this next closest system.
What did we find out about it?
So since it's the closest one, it's the one we're most likely to study in detail in the coming decades. We do know that it's not very massive. It's not the size of Jupiter. It's more like the mass of the Earth. We don't really know much about its surface, its atmosphere, so a lot of details, but since it's so much closer than other exoplanets we found, we're hopefully going to be able to find much more about it in the coming years.
So, Susan, tell us about the number 7 story.
Our number 7 story this year is about the Flint, Michigan water crisis. Back in 2014, the city of Flint decided to change its water source from Lake Huron to the local and cheaper Flint River. A few weeks after that, they began to notice that their water was a little discolored and sometimes had a funny smell or a funny taste to it. And a few months after that, they noticed that there were elevated levels of lead in their water.
Why was this happening?
When they switched to the Flint River, they no longer were adding anti-corrosives to the water, even though there were corrosive elements like chloride in the water. Over time, the chloride began to eat away at the mineral layer that is on the inside of the lead pipes that prevents the water from coming into contact with the lead. So once the chloride was corroding that, the water came into contact with the lead, and the lead was leaching into the water.
So what have they done about that?
They've since switched their water supply back to the Lake Huron water, but the damage has already been done to the pipes. The water is still exposed to the lead, and it can take years for that mineral layer to grow back again. So they either need to replace their lead pipes, which is incredibly expensive, or wait for that layer to grow. And in the meantime, they're having to use bottled water for everything from drinking, cooking, and bathing.
Well, hopefully that situation will be resolved in 2017.
Our number 6 story is about the Nobel Prize in Physics. Megan, tell us what's so special about this Nobel Prize.
Well, sometimes the Nobel Prize in Physics is awarded for something really specific, like the discovery of the Higgs boson particle. But this year, it was awarded for theories that have kind of revolutionized not only physics, but they could kind of revolutionize our whole world of computing and electronics. The Nobel Prize in Physics was awarded for theories that explain exotic states of matter.
What does that mean?
Well, we're all actually familiar with phases of matter. If you think of something like water, water can transition between
Solid.
Liquid.
Gas.
Yes, exactly. And when we change the temperature, right, water will change back and forth between those different phases.
Water's not very exotic.
Well, other things can transition between phases too, like electronic properties. And the physicists that were awarded the Nobel Prize were interested in these really strange phases of matter that can happen in materials that are really, really thin, like only a few atoms thick, and really, really super cold. And under these conditions, all the normal bouncing around of atoms can slow down and the laws of quantum mechanics take over. So you can get these exotic phases of matter, which are things like superconductivity.
That's so cool. What can we do with this?
Well, what's really exciting about these theories is not just the theories themselves, but what's actually happening with them now. So now there are scientists that are using these theories to actually make materials that have all these exotic properties. And so one of these materials is something called a topological insulator.
What does that mean?
So a topological insulator is a material that is both a conductor and an insulator at the same time. So most of the material is an insulator, so it doesn't conduct any electricity, but just along its edge, it carries this perfect and indestructible electric current. And what's really exciting about that is these new materials, like topological insulators, could be the key to our future in computing.
So from physics to biology, tell us about number 5.
Our number 5 story takes a look at a potential cure for HIV, or the human immunodeficiency virus. There are 36 million people worldwide living with HIV, and while there are many treatments for it, we have yet to be able to actually cure it. Because once the virus goes into the body and causes all the varying symptoms, well, we can get rid of the virus, but the genetic material of the virus gets incorporated into the human DNA, and that DNA stays in there.
So what did they do about that?
There's a new technology called CRISPR, was on our top 10 list last year, and it's a way of identifying very specific sequences of DNA and being able to cut out those pieces of DNA. So we know the genetic code for HIV, we can identify it with CRISPR, cut it out, remove it from the human DNA, and then all that remains is the human DNA with none of the viral genome left.
So how far are we along towards using this in people? Is it being done in theory, in a lab?
So far, it's been really successful in a laboratory setting using human cells, but not in a human, just in a dish. They hope within the next year or two to eventually move into humans to see if it really can be the cure that everyone hopes it is.
So now Megan is going to share with us our number 4 top science story. Our number 4 story is climate change. 2015 was the hottest year ever recorded, but 2016 is on track to beat that, with July 2016 being the hottest month ever recorded in history. This year, we've seen an increase in severe storms. We've seen more powerful wildfires in the U.S. than ever before. And thinking on a global level, our carbon dioxide in the atmosphere was measured at about 400 parts per million.
So what does that mean?
Well, for reference, 350 parts per million for carbon dioxide in our atmosphere is considered a safe level. So being at 400 parts per million means that we're currently at an unsafe level of CO2 in our atmosphere.
So I understand the, increased temperatures, increased carbon dioxide, but what does that really translate to for, let's say, living organisms?
Unfortunately, it means that we're going to see devastating impacts of climate change. And one of those actually happened this year in 2016 with the first known extinction of a mammal species due to human-induced climate change. And that was the brambleKey malomus.
What is that?
The brambleKey malomus is a rodent, and it lives on BrambleKey Island, which is just off the coast of Australia. And that BrambleKey Island was the only known location for the brambleKey malomus. This island is low-lying, so it's particularly vulnerable to effects of climate change like rising sea levels or severe storms. So when those impacts of climate change started to hit the brambleKey Island, the vegetation on the island started to be destroyed. The brambleKey malomus relied on that vegetation for things like food and for shelter. So as that vegetation decreased, unfortunately, so did the brambleKey malomus population. And it decreased so much that it eventually led to its extinction.
So what does this mean for other animals?
Unfortunately, this extinction is just the beginning, and 1 in 6 species are currently vulnerable to extinction due to human-induced climate change.
Our number 3 story is awesome. Karen, tell us about it.
Our number 3 story for 2016 comes in with commercial spaceflight. Traveling to space, whether it's sending humans, whether it's sending supplies, or even just satellites, is expensive and complicated. So one of our companies here in the United States, SpaceX, is looking towards reusable rockets.
So how would a reusable rocket work? Don't they usually get destroyed?
Yes, and that's what SpaceX is working towards. So their attempt is to launch a rocket, and instead of it being destroyed upon re-entry, is to actually safely land it upright to be refueled and reused, potentially even on the same launch pad that it launched from, making it much easier and less expensive to send the next payload to outer space.
So has this worked yet?
So one of their early attempts in 2015, their rocket was not destroyed upon re-entry, and they attempted to land it on a barge in the middle of the ocean. It came down, it sort of put its feet down and landed, and then unfortunately it tipped over and exploded. Now, SpaceX doesn't like the term explosion. They prefer the term rapid, unscheduled disassembly. After learning from those previous attempts, in 2016, they've had several successful landings of these rockets.
Have they reused any of these rockets yet?
SpaceX expects their first reused rocket to launch in early 2017. We'll have to keep our eyes and ears out to hear how that goes.
Our number 2 story, a lot of you probably heard about because of the relation to the Olympic Games in August. It was big in the news over the summer. So, Megan, can you tell us about that?
Our number 2 story is the Zika virus. Zika is a virus that's primarily transmitted by mosquitoes that live in tropical areas. So most of the cases we've seen in the U.S. have been in Florida, but it can also be transmitted sexually through bodily fluids, or it can be transmitted from a mother to her unborn fetus if a woman is infected when she's pregnant.
So what are some of the effects of the Zika virus?
Well, for many people, the effects of Zika virus are actually pretty mild. About 80% of the people don't even know they have the virus at all. About 20% of people who are infected, they only see some mild flu-like symptoms. So one of the biggest concerns has been when women are infected when they're pregnant because of some birth defects that have been linked to the Zika virus.
So what was the main birth defect they were seeing with it?
So the most notable birth defect that's been linked to the Zika virus is something called microcephaly, which is when an infant is born with an abnormally small head, and in severe cases, they can actually have an underdeveloped brain. So this is something that's been a big concern, and there's still a lot of research going on to understand the links between the Zika virus and microcephaly.
So what's being done about it?
Well, right now there's a lot of international collaborative research going on to combat the Zika virus, and some of the things they're working on are the search for a vaccine to prevent the virus altogether. Another thing people are working on is actually just controlling the mosquitoes that spread the virus. And so this can be done using traditional methods like spraying insecticides or removing standing water where the mosquitoes breed. But now there are new ways to control mosquitoes, such as genetically modifying mosquitoes and releasing those into the population to prevent the mosquitoes from breeding.
So it sounds like there's a lot of promising research that has come out of this, and hopefully we'll see a vaccine or better ways of controlling the mosquitoes in the near future. And now, our number one science story of 2016 is
the confirmation of the existence of gravitational waves. This is something that Einstein theorized 100 years ago. He came up with a lot of really great ideas about how the universe works. We were able to prove some by observing the universe really quickly. For this one, it took 100 years to actually build an observatory that can detect gravitational waves. But to really understand them, we have to think about gravity like Einstein did.
And how did Albert Einstein think about gravity?
Instead of an attractive force that pulls objects towards each other, he thought of it as a distortion of space itself. So a massive object like a planet or a star will actually squeeze the space around it so that something traveling nearby might have its path changed. We confirmed that just a couple years after Einstein predicted it.
But what is a gravitational wave?
So when these massive objects like stars are moving, then the distortions in space that they create can move as well, almost like ripples across the surface of a pond, but in 3 dimensions. So we call these gravitational waves. We can't detect them with any traditional telescope, so we had to make a brand new type of telescope to try to detect them. The Laser Interferometer Gravitational Wave Observatory, or LIGO, is 2 perpendicular tunnels, 2 miles long each. By measuring them really precisely, we can see the effect of a gravitational wave passing across the Earth.
Do we know what caused those gravitational waves?
So the 2 observatories that were built, one in Washington State and one in Louisiana, were set up so we can detect not only that gravitational waves exist, but a little bit about what caused them. And in this case, it was 2 massive black holes orbiting really closely and then colliding with each other, sending these shockwaves throughout the fabric of space, all across the universe, and eventually to the Earth, where we were able to finally detect them.
So why is any of this important?
So it really advances our understanding of some of the fundamental physics of the universe, but it's also really exciting because it opens up a whole new field of astrophysics. There's things that we can't see with our telescopes, much like gravitational waves, things like the center of galaxies. If we use our new observatories to use gravitational waves to look at them, we can learn more about the universe than we ever have before. Ever.
And that has been our choices for the top 10 science stories of 2016. Thanks for listening and Happy New Year!